So hello guys. Today we will start the circular linked list. Okay. So it will be a full video on circular linked list with adding element, deleting element, traversing the circular linked list, and so on. So after this we will go to some other data structure like say a stack or queue or tree or graph, something like that. So yeah, we will cover stack and queue first, then we will go to tree and graph. So first thing first. So if you want the code, so you can just access the code from my GitHub repository, which is this. You can just go in there and just click in this code and just copy it. If you are using SSH, then you can also use SSH too. Okay. So this is the link of the GitHub repository. I will also paste it to the description, so you can check that out from there. Okay. So let's get started. So let's jump to the OneNote. Okay, so uh, what is the circular linked list? Circular linked list is a basic, it's another implementation of linked list where you use the node in a circular fashion. You will see when I get started with this. So what what it means is actually, say there is a node like this. Okay, so there is another node like this. There is a node like this, and there is also a node like this. So I'm putting it in a round fashion. Okay, so now this is my head pointer, head node. Here, from here our link is getting started. So let's just name this as A for now. So it's pointing to its next node. Okay, fine. So it's pointing to this node, which is B, and then its next is pointing to C. Okay, so now its next is pointing to D, D node, and the D is pointing back to the head A. Fine. So this is actually a circular linked list. So if I draw it a bit good, a bit design manner, so you can just show it like this. So see, this linked list is connected and it's coming back to the head. Okay. So this is a completely connected linked list where the last node is pointing to the head, where it's getting started with the pointing stuff. the same data structure of node in all kind of linked lists. So the node is the same part. So we are going to just copy it out. So if I go there and we are going to copy this cp node dot cpp first, and where we're going to put this is dot dot slash. We're going to the one directory back, and then we're coming back to the what we're going to the c linked list. um, Linked list. Okay, so this is what we're going to do, and it will copy the stuff, and the next part is h, the header file. We are also going to copy the header file. Okay, done. So now we are going back to the our actual repository of c linked list. Okay, so now we have this. Up till this is done. Okay, so we have a node. If I start with nvim dot, okay, so we actually have a node.cpp and node.h and also a main.cpp. Okay, fine. So there is one make file in here, and also if we check, there is node cpp which is already implemented like this, and there is node h which is also implemented like this. Okay, so we have node. So what we are going to create is another file called c linked list dot uh, c linked list dot h, a header file. I'm not sure why I'm putting the name as like this, but let's just go with it. C linked list dot cpp. Okay. Okay, fine. So the first thing we are going to open is c linked list dot header file. So in here, okay, before that, let's just properly set up our main.file. Okay, stream, fine, using, let's not use any namespace. Again, this is not mandatory. Doing the return, you can just return nothing and it will return 0 by default. So okay, so this is the basic stuff is done as of right now. So oh sorry, I have got the wrong folder, wrong file. So I have to come back to this. Okay, fine. So first thing we are going to do, f and f is, what will be the name? The name will be c linked list dot h. Okay, so we'll check about this. And one more thing, I'm going to remove this debug. Okay, 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 hold on, let me just remove this. And what we are going to do is we are going to define a c linked list h header file. Okay, done. And now we are going to properly set up our class c linked list. Okay, so this will be our class. Firstly, what I'm going to do is what should we have actually. Let's go back to our OneNote and let's just check it out. So the first thing in the implementation that we should have is actually a header pointer, right? A head to point on. Okay, and there is one more thing I want to have is a tail pointer, which is not necessary. You can just go ahead and don't include this tail, but I'm going to include this tail because it makes lot of things very easier, like adding something to the tail. We don't have to traverse to all these parts. Okay, so there is no null pointer to stop to. We are going to check the next pointer. If this is head, then we will stop. Those are the logic of finding the last node. So if the next node of any node is head, then that node is the last node. So I'm just going to implement a tail which will be pointing at the last node. So that will be very much easier for me to add anything to the last node by including just the tail. Okay, so the first two things we should have is this tail and this head. These two things we must have. Okay, fine. Now what we should have in the next part is we should have a constructor, C linked list constructor. So in this constructor we should pass a value to initialize to start the linked list. So when the value is passed, the head and tail will be pointing towards this pointer. So it should be pointing to itself. Okay. So now when we add, then it's going to increment the total nodes. So we are also going to use the, okay, we are not going to use the total nodes in here anymore. Okay. So these three things, first we have head, tail, and this uh, constructor. Okay, so let's just go to our terminal and start with that. Okay, so the first thing we should have is let's just make this a public. And okay, okay, I have messed up some things. Okay, this is not expected, but I'm going to remove this anyway. So what I'm going to do is I'm going to select everything and just shift it one bit and just go in here and just put it like this and start writing our code from here. Okay, so the first thing we should have is a node pointer, node star. Okay, include node.h, which is, yeah, we should have that. Okay, fine, no worries. So we should have a node pointer which is going to be called as head, and there should be another pointer which is going to be called as tail. Okay, done. And we should have our constructor called C linked list, and this should accept a value which will be integer. Okay, you can take any kind of value in here. You can take strings. That will also work, but for now we are going to take this only the value, and we'll walk through our way. Okay, fine. So this is the all the things we need for right now. Let's just firstly let's just do it like this. Okay, so what I'm going to do is I'm going to delete this, and okay, we are ready. Okay, so let's just go to our C linked list CPP, and in here the first thing we are going to include is include IO stream, though it might not have any need in our file, but let's just include it anyways. Okay, include, and then we are going to include the header file for C linked list. Okay, okay, done. So now we can just call our C linked list file. Okay, so what I'm going to do is I'm going to call C linked list. Okay, this should call it. Okay, so what are we going to actually do in here? So the first thing, let's just set up the whole function first. Okay, then this value should initialize a node first, then do stuffs. Okay, so let's just also take include node.h. Okay, if I'm not wrong, this is the file. Okay, so this will first create a node star, new node, and it should create a new node which is going to be new node like this, and it should accept the value in here. Okay, fine, so we are done in here. Okay, now what we should do is we should initialize the its next value to itself, right? So uh, let's just first add this head to this head should point to new node equals to be new node. Okay, fine, and this should point to tail also, new node. Okay, fine. So those stuffs are done. We are pointing to the same thing. That is good. After that, what we need is, like, we want to achieve like this, so we can just now uh, just call this and head and also access that node, and also we can just do it like this. So new node, set next node address to what itself, right? So new node, so it should do that. Okay, which is done, and we should paste it up here. Okay, so that's pretty much done. That is what our constructor will do. Okay, fine. So our constructor part and also the uh, header part is okay, done. So now what we should do is we should implement a traverse function so that we can check all those stuff. So let's just first go to our main.cpp and firstly determine what we are going to do with this. So firstly I'm going to be including the header file. For that, include c-link header file. Okay, fine. And what we should do is we should call c-link the class, and we should initialize this to uh, trial list. So we should name it to trial list, and we should construct a checked out of it instance. We should pass a value. Let's say I'm passing a random value of 77 for now. Okay, this should work. Yeah, pretty much ready. Okay, so our constructor is ready for testing. But for now, let's just go and understand what we are going to do in Traverse. So if I go back to my OneNote scene, so what we should do in Traverse actually if I draw the linked list right now in correct manner, so how should our linked list look like? So if I properly draw it, it should be like this, right? So let's say this is our A, this is our B node, and this is our C node, and our head is now pointing to this, and our tail is now pointing to this, which is good. So in circular linked list, this should point back to A, right? So this is our circular linked list actually. So what you should do, exactly the same thing we have done with the our normal linked list, we can do it in here also. So but we should mention a stopping function. Okay, so when we should stop traversing to the linked list, so we'll come to here, print this. So we are starting from here, a temporary pointer which is going to traverse to this. So this will be going to be our iterator. So let's say, let's give it a value. So this is going to be 11, this is going to be 21, and this is, let's say, going to be 35. The values they contain, the node content. So the pointer should come to first in this, so it print out 11 from here. It will go to the pointer's next location. The pointer now is equals to pointer's next location. Pointer is now equals to pointer's next location. Okay, so it will point to this, then it's going to print 21 in here, and then it's going to perform the same thing again, and after performing the same thing, it's going to print 35. Now if I keep doing this, then this loop is never going to end, right? It's going to be going forever and forever. So we have to mention a stopping function. So our head is pointing to this. So in every node case, after running this, okay, whenever we're trying to run this, before we are going to check if ptr's next location is equals to head. If this is equals to head, then we are going to break the loop. Okay, fine. So we can try to inform it in a different manner. So we can implement a while loop in here, and we'll say the loop is going to be continuing until the ptr next node is not equals to head. So whenever we find that ptr's next node equals to his head, we are going to stop. Okay, in this fashion, if we start like this, so if we are pointing to this head, so head is not going to be pointing to head. So if it's going to be pointing to head, then we're going to close the loop, right? Fine. So what we should do? We should do is, let's say, let's first diagram this. So the PTR is not pointing to head right now. Okay, fine. It's taking entry in here. Okay, fine. So PTR takes entry because this is pointing to this, and it's run the code and print 11 in here. And if after that it's going to find this, okay, 11. Okay, so it's going to run this. So now it's printing 21, and it's going to the next step. When it is pointing to the tail's next part is head, right? So if my pointer is pointing to tail, so it's pointing to this part, it's coming in here and it's checking the next part. So it's not head, right? So now the problem comes. If it's not head, it's not going to print this stuff, right? So it's going to exit the pointer. So we are not going to be printing tail. So that is a problem. So what we should do in here, we can write a function like this while true. So it's going to run forever while true, and every time we run this thing, we should first check up that ptr.next is equals to head. If ptr.next equals to head, then what we are going to do is we are going to break this function. So in this fashion, if we are going to do this, then we are going to print everything. Okay, fine. Okay, so I think this is going to work. Let's just check it out. Okay, so let's just go back to our terminal first. So implement one by one things. So let's just go to in here. Okay, so let's just go to our linklist.h, and let's traverse in here. Traverse. I don't know if I've spelled it correct or not. Okay, traverse is going to be a void function. Okay, fine. This is done. So this should do it. And in our linked list.cpp, I want to include those stuffs. Say link list and include the traverse method, and it's going to contain nothing, and this is a void function, so it should mention the void first. Okay, this is done. So in traverse, what we are going to do, we are going to first make a pointer to a node. So it's going to be hit node star, which will be our iterator, and which will be pointing to our this dot head, right? Head. Okay, so at this stuff we are done. So what we are going to do is we are going to run our true function, which will be like this. So you are going to print everything, right? So what we are going to do is we are going to print the iterator's value. So std cout, and we are going to print it like this, if I'm not wrong. Iterator, what was our function's name? I just forget. Let's just check it out. Get stored data. Okay, so this was our function. So let's just not put anything in here for now. We are going to just enclose it with a tab. I need to run it on, and if we will check if our iterators next get next node address is equals to our this dot head. If it is true, then we will what we will do is we'll break the function from here, okay, from this separate. And if it's not true, then we will continue doing our stuff. So we'll update our iterator as it is. Iterator equals to this iterator, and iterators get next node address. So this will be our new iterator, which will be our next address. Okay, fine. And we will keep doing it until we find our next node where this is a head pointing to head. Okay, fine. So up till this is okay. So now what we should do is we should also make proper arrangement for this. So we're going to print an A for this, so it will generate a new line for this. Okay, fine. So now if I go to my main.cpp, and let's just for now, for our purpose, checking purpose, let's just run this. Okay, so I have okay, so I think we just did something wrong. Well, this should be like this, trial list. My spelling could be a bit wrong, but that's not the point in here for now. So we'll put it like this and we'll check it. So the first thing we are going to do is make our makefiles. So our first makefile will be output, if you remember. So it will be dependent on main.o, and clinkList.o, and also it will be dependent on node.o if in future we change anything in those node files. So we'll do it like this, and every time anything changes we'll run g++ minus g++ main.o clinkList.o node.o will create a file which will be named as output. Okay, fine. Up till this is good, and also we're going to run as output. Okay, fine. So output part is done. Now the main part, main.o, and main.o will be dependent on main.cpp. Okay, fine. We're going to run is g++ main.c main.cpp, and it will going to generate main.o, and the same stuff we're going to repeat. Okay, so linked list.o, it should say linked list.cpp g++ minus c linked list.cpp. Okay, it will generate so. Fine. And at the last step we are also going to do a node.o which will be dependent on node.cpp, sorry, it will be cpp g++ minus c and node.cpp. okay, done. And there should be a clear function. Okay, what it should remove is minus rf, and then it should remove output file, and also it should remove minus rf, and it should remove anything regarding .o format. Okay, so yeah, it should do that. Okay, so for now we are not going to put @ so we will check that out later. So for now our file is, I think, is ready. So if we quit, okay, so ls, and if we run make, so it's going to run this, and this is printing out pretty much okay. Okay, so yeah, this is working. So our initialization and traversing is kind of working. So if not sure, after implementing adding, I will check that if the traverse work properly. So let's go to traversing part, not traversing, adding part, adding stuff to our linked list. Okay, so let's just switch to our OneNote scene. So okay, in next part we will see adding a node. Okay, so adding node to the last, adding node to the first, adding node to the index point. So the traversing part is done. So traversing is done, and creating and initializing constructor is done. So constructor is done. Traverse is also done. So you are left with add to last, to fast, and to index. We'll go one by one. Okay, so first implement the first, then last, then index. Okay, after that there comes the deleting stuffs. Okay, so this is all for in this lecture, first and index. Okay, okay, fine. So this is all. Okay, so yeah. Okay, so we will get started with adding new element to the array. Not array, sorry, linked list. So let me just jump into that. Okay, so first adding new element at the index of last index. Okay, so this one. So let's just add an index to the last index. So what was our linked list? It was like this. So each node pointing to the next node, and the last node pointing to the head node. So this was our head, this was our tail, and A node, B node, C node. So let's say we are going to add a new node in here. Okay, so what we should do at the last position? So firstly we will create a node star A, which will be a new node, just a second, new node. And next we will do is we will point this next value, set next to where we will set this next to the head, because now this will be our last node and this will be pointing to the head. And now what it should do is tails next node, set next node should be pointing to the new node A, right? So it should be like this. So the setup will be like this. So we'll first create a new node and then set the new node next node to the head, and we'll set the tails next node to the new node, and then we will update the tail to our new node A. So this will be our adding a element to the last. So let's just go to it and implement it right away. So let's just jump into my terminal. Okay, so clear an lscd data structure. Okay, so ls. Okay, let me just see one thing. Get add dot get commit -1 linked list setup. Okay, so done. Let's just go to it. Okay, so let's just open up our IDE and go to where was I? The c dot linked list part. So the first thing we're going to do is we'll expand this and we will go to here and say void add new node. Let's say add node to last. Okay, fine. So this will be this, and it should accept a value which will be our new value. Okay, so and also let's just add some also the new things. Okay, so add node to first int value. Okay, done. And also void add node to index. Okay, so this will receive two things. One is the index, which will be indicating the place where we are going to input the node, and the next one is the value. Okay, done. So our implementation is done, declaration is done. Now we will define those methods. So the first thing is void c linked list, and the first one being add node to the last. Okay, so it will receive a value and value, and what it's gonna do actually, it's gonna, if I go to my scene, you can see it's gonna first make a new node and set its value to head, then the tail's next value to a, and the tail should be a now. Okay, so let's go one by one. Okay, so come back here, let's create a new node star node pointer, sorry, not node pointer, which will be our new node pointer. New node equals to new node, and which will be receiving the value like this, and the new node set address value should be pointing to where this head, right, this head. Okay, so let us put like this for our same purpose. And the next thing what we are going to do is we are going to update the tail, right? So now this tail, okay, this field, this tail's next value, next will be the new node, right? So set next node address will be new node. Okay, done. And the last thing what we are going to do is we are going to update the tail. So now this tail is basically our new node. Fine, this is done. Sorry, not like this. Okay, so we are updating the new node 2 is done, because what we are doing actually. So let's go through one by one. So the first thing is we are creating a new node. Fine, we are done with creating a new node. Then nextly we are setting the new node's next address to the head, so it will be kind of like a circular thing. Okay, done. And the next part is where we are putting our tail's next node to the new node. We are pointing our previous tail to the new node, and now in the next line we are updating our new node tail value, right? So we are updating our tail value. Okay, fine. So this will be our add node to the last. Okay, fine. So next what we are going to do is we are going to implement the next part, which is add node to first. Okay, so int value, which will also be receiving a int value. Okay, fine. So let's just put it like this for now, and let's just go back to our one node to see. Okay, so adding new value to the first. Okay, so what we should do actually, so here we should follow 3 steps actually. So firstly, there should be a new node. So node star a equals to new node, which is the same as the first line. New node, we are creating a new node because we want to implement and we want to input a new node in here. Okay, so to put a new node here, now we have to do 2 things. The first, we have to update our head to the new node. So first let's do one thing. We are going to update this A's next value to the current head. So set next to the current head, this head. So the current head. So now the new node, which is this, so let's name it temp. So temp temp is now pointing to a, right? So now it is pointing to a, and what we are going to do is we'll update the tails next node. So tails set next value value to this A. So let's just do one thing. Let's just firstly do one. What we're going to do is we're going to update our head, right? So let's just do it in here. Update our head to the new node A. And now we should point our tail's next node to our head. This head. Okay, done. So this is the steps we are going to follow to implement adding the first node. Okay, so let's just go back to our terminal and yeah. Firstly, we are going to new node. Okay. New nodes. New nodes. Set next node address will be our this dot head, right? So we'll be setting our new node equals to head, and we'll be updating our head part, and we're going to implement that tail's next node to now point the new head node. This is already updated at the previous line. So this is everything we are going to do. We are going to first implement a new node, this one, and now what we are going to do is we are going to set this next node next address to head, which is the current first node. And now we are going to do is we are going to set the head new address to the new node. So now the head is updated, but the tail is not connected to the new node, it's connected to the previous new node. So we are going to implement a line which will be updating our tail's next node to the current head node, the updated head node. So it is done also. Okay, so what we're going to do is let's just save this. Okay, this is done, and let's just create the last part, which is add node to it. Okay, fine, which will be receiving two things. One is the index and the next one is the value. Okay, so done. We're done with this. So fine. Okay, now what you should do, right? So before we do that, so that we can see, we'll do one more thing. In here we'll simply put like this. I don't know if it is okay, so we'll do this like this. So, and what we should do is we should increment one more thing in here, is this, and implement a comma between them, and also do a closing statement like this. Okay, so in here what we are going to do is we are going to implement one more thing so that we can see clearly. So we are going to put our new iterators get next node address. We also want to see the next node address of this iterator. Okay, so this is done. Okay, so this is, I think, up till this is okay. Okay, so now it should print out some basic stuffs, right? So it's not only going to print out the stored data, it's also going to print out this data, right? So also we are going to print it like this. So now it should print all the nodes in their separated line. So let's just do one more thing. So we should include something which will indicate it like this: printing linked list. Okay, so this should be like this, and it should also contain this. Okay, fine. So we are done with printing the stuff. We are updating our traverse method, which is good. You will see why I updated the traverse method. This will help us to identify which is the next node of this. Okay, so it would spit out some value, you will see. So let's just go through it and let's just see what kind of value this will make. So let's go back in here and let's just check if there is any value. So we should go to our linked list, and in here let's just make our file, make, and it will run all of them. So see, it's pointing to this node, which should be its own address, right? Because right now there isn't anything in here, so it should be pointing to its own address. Okay, fine. So let's just go through it again and make some changes. So we'll implement the index stuff. So if I go in here, so let's just go back to our OneNote and see what we can do about the index stuff. Okay, so the first thing, I'm going to remove this whole part about adding value to its last and all those things. So I will just keep this node A in here so that you can see. Okay, so node star A. So to implement this, I will take another variable called total, which I already did in the previous video. Total variable, no, not total variable, total elements. You can name it anything like size, length of the linked list, anything like that. I am going to name it total elements. Okay, so every time I add a list, we'll update this total linked list. So it will be first set to 0. Okay, so let's just do that. Let's first set it to 0. So in terminal we should set it to 0. So let's just go in our header stuff and let's just put one thing: int total elements. Okay, fine. So we are done implementing our elements, which will help us to identify if the user is passing a wrong index. Okay, so let's just do one thing. So the first thing we should update is we should update our add functions, right? So first thing is whenever we are adding a new node, so in the constructor we are adding a new node, which should make this to total elements to be initialized to 0 first. So let's just not do two things at once. Let's just do one thing. We're going to implement it to 1 by default because we are already implementing a new node inside this. So we will directly select it to 1. So after that, when we are adding a new node to the last, we should do it like this: total elements should be plus plus, right? So plus plus, that should update the new node. So let's just delete it and let's just go to the new node, and okay, so fine, we'll update the last as also. Total elements, it should update itself by 1. Okay, increasing itself by 1. Okay, fine. So now we are done. So let's just implement the logic for adding a node to the index position. Okay, so let's just go back to our OneNote. See, so creating a node is mandatory. So we are going to create a new node, which is mandatory stuff. So we are going to create this. Okay, now what we are going to do, we'll start with the head node. So for now I am going to remove this temp. Okay, so we are going to make a iterator it, which will be pointing to the head. Okay, so now we want to find the index which where the person is passing. So index, for now I am going to mark all of this 1 2 0 1 2. So if the person is firstly, if the person is giving me a large number, large index, which doesn't exist in here. So we should add it to the last. So we should call add to last, which is clear. If the person is giving me a very low index, so we should pass add to the first. That is also done. So now if the value is between them, between this 0 and 2, so what we should do? Should properly traverse to it, right? So first thing we should do is should try traversing to the previous element of that element. So let's say the user give me a 2, not 2, let's say the user have given me a 1, index number 1, append 77 data 77 at index number 1. So what we should do? So for now, for this reference, I'm going to create a separate kind of thing. So this and this should point out to this, reach out, and this should be like this. So our circular linked list is like this, and this is our head node, and this is our tail node T. So 0, 1, 2, 3, 4. So all of them is like this, and this is our PTR. Okay, so the new pointer. So it should traverse, right? So what it should do? So let's say the for now let's just update it to 2, so just we can see. So we'll want to reach the index 2, right? So we have a index value which is passed by our user, which is set to 2. Okay, so we should traverse to what? We want to implement a node in here, right? So in this position. So what we want to do is we should traverse until we reach to 1, which is index minus 1. So we should be able to traverse to index minus 1 position, this position. So the pointer should start from 0, okay, and the pointer should stop at index minus 1. Okay, so this will be our this should return this pointer, this node, the previous node from this, right? So this should stop at here. Okay, so done. So we get the pointer from here. So now what we should do? We should update this pointer's next node to be this node, the index 2 node, idx2 node, right? And now what we should do is we should sorry, we made a mistake. It should not point to the index 2. The pointer's next node should point to the newly created node, which is A. So this should point to A. Okay, fine. So in here, if I remove this, in here we are putting a new node which is called A, and now this next pointer is not pointing to this 2. This is pointing to this A, right? So it's pointing to this A, and remember we want to implement this A in the second index, so it is pointing to the A. So now the A should point, sorry, we also made a mistake in here, because if right now we point this node to the A, then we lost the value, the address of the second node. So should somehow contain this second node address. So what we should do is firstly we should do is A's next node should be point to in the IDX of 2 node. So the first thing it should do is it should point to this node, right? So now down the new node is pointing to the next address, which is the index 2 node. Okay, fine. After that we should implement this. PTR's next node should be updated to A. So now this link is not in here, so this link is pointing to this. So we're done with the implementation. Okay, so now this is our second, and the update is going to be moving forward, and also we should update our total value to plus. Okay, so this will be our implementation. So let's just first implement this for loop. Okay, so let's just go back to our terminal. Okay, so let's just go back to our terminal, and we should firstly create our new node, which is new node, You can implement it in other ways also, but let me just do it in like this, which will be set to value. And now what we're going to do is we are going to implement the looping method. So the loop should start with uh, int I equals to 0, and the loop should stop at before the idx reached, the index value is reached, right? So in this function, what we should do is we should update our I, so the loop goes continuing on. So inside this, what we are going to do is we are going to update our index value, right? So not index value, our iterator position. So we should create an iterator which will be leading us to the head. So let's just create a new pointer which will be pointing to iterator, which will be pointing to our this dot head value. Okay, fine, we are done with this. Okay, so before we do that, we also want to implement something like this. And if the index is greater than equals to our this dot total value. Remember, total value indicates not the indexes, it indicates the total number of elements present in that. So if there is 8 elements, so the highest index should be 7, right? So that's why we are putting a greater than equals to. If the index is coming 8, then there is no position called 8, so we should update it to 8. Okay, so this dot total elements. So what we should do is, if the index is greater than this, so we should call this dot add element to the last. So and we should pass the value like this. Okay, so done. And also let's just not make this like this, we should do it like this. Let's just copy in and paste in it here, just delete it, and let's just increase this like this. Okay, fine. So up till this, we also want to do is, if this is done, should return nothing. So let's just do one thing, we should change our progress to like this. So let's just return something like this. Okay, so it should be like this, and we just return 1 for now for our purposes, so that we can enclose the whole thing. Okay, so why we are putting int in here is because we want to close, we don't want to continue the whole thing. Okay, so we want to return after this. If this is this, if the condition is true, we want to return from here. Okay, so also what we want to do is we want to implement another thing called greater than less than equals to. If the whole value is less than equals to 0, 0th position, so what we should do is we should implement another thing, is this add node to first, we should pass the value in here. Okay, and also we should return 1. So this way we can keep track of everything. Okay, now if none of this happens, then we are going to try implement this. Okay, good. So if none of this condition is true, we are going to be doing this stuff. Okay, so fine, up till this is good, we are doing some progress in here. Okay, which is good. So this is this. Okay, so first we should do is we should update our header file so that it can be casted to int. Okay, fine. So now it shouldn't throw any kind of error. Use the undeclared identify new. Did you mean? Okay, so what is happening in here? Okay, so I have put the name new. Okay, so this should be like this. Okay, non-void function. Okay, we will see what we are going to do. Okay, fine. So the first thing, let's just update it. So what we should do, we should update our iterator, right? So what we are going to do is we are going to update our iterator. So iterator equals to, iterator is going to be equals to iterator's next value, next next get next node address. Okay, so this is all. So let's just check, otherwise we will make another mistake like the previous one. Remember, we made a mistake in that thing. So let's just keep it short and make something out of it. So let's just delete it and be like this. So let's just check it. So if my index is 2, so the iterator should point to first index right now. So I is starting from 1. So now what it should do, it should start, it's starting from 1. Okay, fine, this is good. So it is going to update itself to 1 by default, and it should stop, right? So by this, it's going to be pointing to 1, which is still less than 1. So it's going to update another time. So it's going to pointing to 2, which is wrong. So we don't want it to point to the next node at that time. So we should enclose it by 1, right? So now this should be pointing to the 1. Okay, so I think now it is done, because now we are not going to run it one more time, because if the index is 1, and then it's going to be pointing to the next node. Okay, fine, this is okay. So this is going to be pointing to 1 if we pass index 2. It will point to the previous node of the node we want to add. Okay, fine. So now we will implement our logic in here. What was our logic? So iterate is pointing to this. So now we should update our new node value, right? So what we are going to do is we are going to be pointing to new node, new node's next value, next set next node value to iterator's next node value, which is get next node address. Okay, so we'll be setting to this, and then we are going to update our iterator which next node value will be set to new node. Okay, by doing this we are probably ready to apply this theorem. Okay, so I think it's done now. So after doing this, we should return also 1. Okay, so our adding new node to the index is done also. So let's just check all of them. Okay, so what we should do, we should first print out the traverse function like this. After that, let's just add some things. Trial list is this, and add, let's just check the first one first. So let's just add a node called 66 for now. Okay, trial list, add node to last, which is false because I put it the wrong name. Trial list, add a node to last, and it should be let's just give it a like what we should give, let's just put it a nice 88, because we are incrementing it by 11 every time. So we are done with this, and let's just put another thing. Trial list, add node to last, not last. So let's just add last for now. Let's just put 99 in here. Okay, so what should our linked list look like? So the first, it should start from 77, then it's going to be like, because we are adding 66 first, so 66 and then 77, and then we are implementing 88 at next, and then we are implementing 99. So the list should look like this. So this is the index 0, this is the index 1, this is the index 2, and this is the index 3 for now. Okay, so now what we want to implement is, we want to do one thing. So let's just do a traverse first to see if this is okay. And what we should gonna do is should be able to do a comment in here. We're gonna add node to last, so which is wrong. why this is why this is giving me a wrong sign. Okay. Okay, so I put it a wrong semantic. Okay, so this is the one. Okay, this is the mistake I have done. So this traverse should print out like this, and now we should do an list trial list. And also we are not going to be doing a traverse in here. What we are going to do is we are going to add a not at a index. So what index should we put? Let's just put for now, let's just put 1 for now, and implement the value of, let's just add a value of 5 in here. And let's just do another trial list add node to index. And next, so what we are going to do is we should be giving it, because the index is now updated, there contains 5 elements. So now there is 5, there is 4, so we should point out to 3. So we want to update the 3, and we want to put a value of 78 in here. Fine. So our new node should look like this. So the first time, if I do a trial list.traverse, it should be like this. So first it was like this 66. So if you see, there was a 66, 77 and all those. So we added a new index, a new element to the first index. So it should be updating itself to here. So it should be putting a 5 in here. Okay, fine. And then it should update itself to 0, 1, 2, 3. So it should be putting something in here. Okay, so 78 in here. So it should be something like this if I'm not wrong. So let's just see what happens. So if we quit and make again, so changed. So see, it's updating itself, right? So if we see, 66 is first, which is okay, 5 is second, also okay, 77. If I forgot the actual how was the order, but let's just see what happens. So this is the node stuff. So 66, 5, 77, 78, 88, 99, which I think it's fair enough, which is true. And also let's just check one thing. So the next node, it's pointing to this, which is this value, right? And the next node is pointing to this, which is this value, this node's value. And this node is pointing to this, which is this node's value. And this node's value is pointing to this, which is this node's value. And let's just match one thing. Okay, so right now our head is this. So this is actually pointing to our head. This is not returning null. So see, this is not returning null. So this is actually pointing to our head. Okay, which is the exact same as this. See, so that's how our circular linked list is going on. So let's just go back to our circular linked list for now, and let's just clear our main for now. We are going to remove this all thing, and also make this change. Okay, fine, we are done with our linked list.h, and let's just go to our new stuff. So all of them are working fine. Last, first and index, adding those stuff. So we can now move on to our deleting stuff from there. Okay, so let's just go to deleting stuff from there. Okay, so let's just go to there, and we'll start deleting stuff from the next part. Okay, so yeah, we'll start it from the next part. Okay, so hello again. Let's just get started with the next part, which is deleting stuff, right? So deleting stuff from the circular linked list. So let's just implement it like this. So how we should delete some stuff from the linked list, right? So the linked list is pointing to this. This is this and this and this. So the first thing we are going to look at is deleting from the last. So what we are going to look at is deleting from the last. So this is our tail, this is our head. Okay, so this is our head and this is our tail. So now we are going to remove a element from the last. So this one should be removed, right? So first what we should do, we should traverse to this before this, right? So we should traverse to before this. So our what we should do, we should point our first node in here. Sorry, not node. First iterator in here, and we are going to traverse it from here. Okay, right? So let's just start traversing. So when we should stop, when we find a iterator which next value is equals to tail, then we should stop our traversing. Other than we should traverse, right? Iterator equals to iterators next. Sorry, I have messed up in here. So it is next value. Okay, so now our iterator should traverse to iteration while, so let's just write it like this, while it's not equals to tail, then we should run. So what it's going to do is, so let's just say our iterators, let's just go to a dry run. So our iterator is actually pointing to the head. It is equals to head now. Fine, which is fine. So it's first check iterator's next node equals to tail. Is it tail? The next node equals to tail, which is not. Its next node is not tail. So it should update it. Alright. So we're updating it. Iterator is equals to iterator's next address. So now the iterator is pointing to this node. So right. So the iterator is pointing to this node. Fine. Then we should go to the next node, right? So it should go to the next node. Now this node, it's going to check iterator's next node is equals to not equals to tail. It's not, its next node is not equals to tail, which is true. So it's going to run this. So now the iterator is pointing to this node, right? It is pointing to this node, which is also okay. And now it's going to check iterator's next address is tail, which is true. So this condition is going to be returning false. So now the while is going to break, right? So now where the iterator is pointing to is the previous node of the tail node. So you can update your add to index with this while statement, which is more efficient, and for you it will be easy to implement because there is no concept of implementing -1 and all those stuff. So I will just leave it to that, but you can update it to this, and you can put yourself in a challenge of updating this whole stuff into this. Okay, fine. So let's just update it. Okay, so update our code with this. Okay, so we'll just go to our terminal and open up our terminal in here, and we should do is we should point a new thing. So let's just, for our understanding, let's just put it to like this. So now in here, the first thing we are going to do is delete node from last. Okay, so it's not going to accepting anything, going to accept anything. So we should also point a void delete node from first. It should also doesn't also accept anything. So the next thing is delete node from index. So now this is going to receive the index, which is okay, fine. Done implementing those stuff, declaring those. Now let's define those things. Okay, so we're going to make a space, separate space for it. Okay, so let's just implement it. Void c linked list. Let me just check if I change the screen. Okay, I changed the screen correctly. Okay, so what we are going to do is we're going to implement the what was that last one. Okay, so let's just implement it. Okay, so what we should do, first we should create a pointer, right? Node pointer which will be pointing to our head, iterator which will be pointing to our this head, which is okay, good. Now what we should do is we should actually apply the while statement to update our iterator according to that iterator, which is this, if until this next node address becomes the tail, this tail, right? So if you see what I did in here is until this. Why I said until this? Because in while, until this condition, this whole condition becomes false, the while will execute, continue executing, right? So now I can just write in here that iterator will be equals to iterators next node, right? So it should be getting updated to get next node address, which is true. Yeah, so it should be updating itself to this. Okay, which is good. Now what you should do, now we are pointing to before the tails address, right? So now what you should do is we should update our tail, this tail to the new address, tail to the new address, so which is iterator, and we should update this tails, the new tails, set next node address, so iterator, sorry, this to head. So if you don't understand, let me explain. So up till this is clear, because we are just by running this while loop, we are pointing our iterator to before the tails node, right? So it is done. After that, what we are doing is we are updating our tails to tail to the new iterator, which is the previous value of the new previous tail. So we are updating this to this, and then we are setting the tails next address to head. We have to make this linked list a circular linked list, right? So this is this. Okay, done. So now what we are going to do is, so let's just implement all the deleting stuff, then we'll check. So let's just implement linked list, delete from first. So now we'll be deleting from first. So let's just go back to our OneNote and see what is there to implement this. So I'm going to remove all of this stuff for now, for sake of the updates. Okay. So what it should actually do to remove this head pointer, so it have to do almost nothing, because we should just update this head to this heads get next node address. So we should update this head pointer to this pointer, which is the next value of the previous head. So now the head is pointing to this part. And now what we should do, we should remove this link and make a new link, implement this, right? So what we are going to do is, we're going to say this tail set next node address will be set to this head. Okay, done. Okay, we are done with this. So what I should do, let's just update something. Okay, so let's just do one thing. So we'll start terminal. Oh, one more thing I just forget to implement is we're going to implement this dot total. We'll decrease our total value, total element to minus minus, right? So we're going to say it's going to be minus minus. And also what we're going to do is um, see, let's just do one thing. So this head should be updated to head's next node address, so which will be head get next node address, which is true. And now true, this is not returning anything kind of boolean or anything, just I just said true for out of practice. I don't know why I said that, but we just forget about that, and let's just go on. So now the tails next address should be pointing out to the new node, right? This dot head. And also we should update our so update deleting from the first is also done. So now what is left? Left part is void selling, which is deleting node from the index, right? So int index and also int value. Okay, we are done. Now let's see what you can actually do in our OneNote. Okay, so deleting from a index, right? So let me just clear it up, it's cluttered up. So let's just, for now, let's just put it back like how it was at the first. So head, and it should be pointing to this. So let's say for now it's 0 1 2 3. So I want to remove this second node, right? What we should do, we should first traverse to this node 1. So what are we going to do? We're going to say that first we are going to initialize the iterator it. So it equals to will be this node, this head part, so starting from head, and we will traverse to what, this 2, right? And we'll traverse to before that node which you want to delete, so from up till here. Okay, so from here we are going to set the next node value to the next node of this node. So not, let's just not write it like this. So buying the doing the loop, our iterator should point to the previous node of the mention deleted node. Okay, so yeah, now the iterator is updated. So what we should do is, we first want to continue the linked list, right? So what we should do is, we should update the iterators. We should first want to cross this connection out, because we don't want to make a connection to this node just for the sake, because let's say because there is no reason for that. I just want to remove this. So what we should do, you can just skip this line. So we want to get access to the node that we want to delete. So get new node, get next node address, it should return the address, and we should set its new node address, set next node address to null. Okay, so null. That way you can say that this node will be collected by the garbage collector, because it's not containing any reference to the current running process. So it can do that. So we'll do this part, and after that what we are going to do is, we are going to update, right? Oh, before we do that, actually, so let's just say we are going to save this value, right? This value, we're not going to update it first. Okay, so what we are going to do is, we're going to save this value. So node star a, so we're going to save this value to a, this node, fine. And then we'll say it set next node address. Remember, the it is still pointing to this node. Also, the node will be it set next node address to where? Set next node address to A's next address. Fine. So the new pointer will be pointing to this. Okay, fine. So this connection is removed. Now what you should do? We should cross out this connection. So we are going to do is A set next node address to null. And by doing this, we are done. So this is the step we should follow. So let's just go through it in the terminal. Let's just go to the terminal and go see what you can do. So let's just first initiate our iterator, which will be pointing to this dot head. Okay, fine, which is good. And now what you should do, we just, what I'm going to do is I'm going to just copy this whole part. Okay, we should copy it out and we should paste it in here. Okay, fine. So now our iterator is done. Iterator, okay, just let me see. Delete node from the index, out of definition line chunk. Okay, what have I defined from index? So I must be doing something wrong in this index. Okay, I think I have done something wrong. I cannot understand this right now. So let's just go to the definition first and let's just open up our definition in here, B. So what did I do wrong in here? Okay. So we are making a mistake. Making a mistake in here. So the mistake is like this. So we are putting a value which we don't want to accept because we are deleting a node, not adding a node. So it should not accept any values. Okay. So now the iterator is added. So what I'm going to do is I'm going to make a temporary variable, temporary node, temp node storage. So it will be pointing to iterator's next node. Sorry, not this. Next, get next node address. So this will be this. And now what we should do is we should update our iterator to what? Iterator's next node to what? Next should be updated to sorry, not like this. Set next node address to be temp node stores next node address. Get next node address. Okay, so our link is continued. And then what we should do is we should just remove the actual link between them. So we should make it null pointer. Okay. Also, I just forgot to do one thing. This total element minus what it's going to update itself. Okay, fine. So I think up till this is okay. So what I'm going to check is we're going to put it in here and we should update our main to see the changes we made so far. So for now, let's just comment out all the traverse we have done previously. So we want to put only one traverse. Okay, so this traverse is okay, but all this traverse before that, we're going to remove this everything from here. Okay, so we're going to remove everything from here. Okay, fine. Okay, done. So now what you're going to do is trial list, and now let's just delete something. Okay, delete node from the index. Fine. Now let's not touch index, let's just touch the last. Delete from the last. Trial list, delete from the, you can just test it out before that also, but let's just formally make it like this. First, so it was first, right? So what was our functions called? From last and from first. Yeah, this is okay. File node. Okay, so we didn't put a e, so that's why the from first. Should be like this. Okay, so what are we actually missing? Delete node from first. Delete node from. Okay, so uh, I'm making quite a mistake. And also this will be a trial list. So okay, I just close it out. I don't know why. Let's just put it like this. And we're removing two things. So we have actually how many elements? 1, 2, 3, 4, 5, 6. 6 elements. So we are removing 2 elements. So there will be 4 elements. So let's just remove an element again. So from where are we going to remove this element, right? So what we're going to do is, so let's just say we are going to delete element from the, so there are 4 elements now present in the list right now. So we should remove the element from the second index. So I think this is done, and after that let's just make a trial dot list so that we can, sorry, trial dot list traverse, so you can see the changes. Okay, so we should quit and make a make. So let's just see what happened. Okay, so the first list was 66, 5, 77, 78, 88, 99. So first we have done, if I remember correctly, last one, deleting from the last. So 91, 99 is gone. The next node is 99 is gone. Okay, so it's gone. After that, okay, just let me update something. So we are making a mistake in here. So in the traverse function, so where is our traverse function? We're going to put it outside of the loop. Okay, so that only one time it is shown. So if I paste it in here, so it should be like this. It should be like this. Okay, so quit. Let's just quit, clear our screen, and let's just make one more time. Okay, so now see what happened is this. So there was 66, 5, 77, 78, 88, 99. So now the first one was delete from the last. So 99 was gone. 99 is gone. Delete from the first was the next. So 66 is also gone. So hold on a second. So okay. So now it is showing something pretty interesting. So it is printing 66 at the last. See? So actually what is deleted in here? So let's just go through it. So what we are getting is this output, right? So let's just copy it out and nvim. So we are again facing problem with the cpp part. So we are going to be in our main folder. So in here what I'm going to do is I'll pasting the whole stuff and making it a comment. So the first one was this, right? So let's just cut it from here. Okay, so this was the first list count. Okay, so what was this? So the first one was 66 because we added 66 to the first, which is okay, good enough. Okay, fine. So the next part was the first one, which is 77. So it should be like after this, but we are adding a point index to the 1, so that was the 5 was updated. So 66, 5, 77, and then we are updating to 78, I guess, which is going to be in the third index. So it is updated to the third index, which is also good. And then the 88 index, so 88 is updated to the last, that was the last, and then we are also adding 99 to the last. So this is done. This is perfectly okay. Now what we are seeing actually is the problem with the delete part. So when we are deleting, delete from the last is okay because we have deleted something from the last, which is good. So 99, so where was our 99? This was our 99, right? So 99 is gone. delete from the last is fine, pretty much okay, I think, if I'm not wrong. Okay, so there is a problem. So if we put this 66 above this 5, so it will be like 66,577, which is this 66,577. Then 78. So 78 is gone because we are removing from the 2, which is okay enough. But let's just do one thing for now. Let's just copy this, make this, and this. Okay. So we should be updating this, also this, and this. Fine. So what I should do? We should just make. Okay, so see what is happening actually. So the first list was the implemented list. The next was we are deleting the last stuff, 66. So 66 is gone if you see. Okay, hold on. We are not actually removing 66 from here. So okay, just let me see what was our order. So our order was actually deleting from the last first, then we're deleting from the first, and then we're updating from the index, right? Index. So first last, then first, and then the index. Okay. So let's just go to our index and let's see what happened. So this was our original list, which is this. We're removing something. Okay, let me see. So after this, we're not removing anything from here, like so. We should be removing something from here. Okay, I'm just making mistake again and again. So let's just, to make sure I know what I'm doing is, I made a traverse. So this was the traverse. So let's just put something in here. Std cout the original list to see if this was working or not. So this was n and done, and let's just copy it, and we're going to be going down from a bit. So we're going to put it inside here. So we're going to paste it in here, and we'll say delete from last. Delete from last. From last. Also we're going to copy this, and we're going to make a copy in here. Delete from the first, and also save this and also copy it down, and we are going to make a paste in here and delete from second index. Okay, fine. So after from listening to the second stuff, so what we're going to do is, so let's just update it from the second index. So let's save it like this, and let's just go back to our original terminal. Let's just clear it out and make a clear, which is not needed actually, but let's just do it anyways. So make, and then this is this. So this is the original list: 66, 5, 77, 78, 88, 99. Fine, done. Okay, now we're deleting from the last, so the 99 is still here, which is a bit of a problem. So we have to update the last, right? So let's just go and check our last first. Okay, so nvim dot, so let's just go to our last. What is happening actually? So let's just go to delete. Okay, delete element from the last. So we are initiating a variable from the last, and we are traversing to the tails value. So what we should do actually, we are updating it to the tail, right? We are doing it to the tail, if I'm not wrong. if I'm not wrong. So if just let's open B and let's check. So we are deleting and then traversing. So yeah, so there is a problem. Let's just go with it. Iterator this head. So we are selecting to the this head. We should be pointing to before the tail, right? So is this okay? Let's just check. Iterator should be pointing to before the head. So our iterator is pointing, our iterator's next node is always checking for the tail. So if the iterator's next pointer is tail, we should stop at that point. We should not update itself. So now if it's not that, then we should update our iterator, right? So iterator is head, and until this is true, it is coming fall. So let's just update it like this for now. So let's just remove the shorthand. Okay, so let's just update it like this and let's just save it. So what we are actually doing is we are checking iterator's getter's address. It's not equals to this tail. If it's equals to tail, then while will be stopped. Okay, fine. If it's not tail, then iterator should update to next address, which is okay because we are already checking the next node is address is not tail. So the tail is updated. The iterator is also updated. The iterator is pointing to the before the tail, which is good. So now what I should do is our tail should be pointing to iterator. And now my tail's value should be okay, I see. So what we are doing wrong is in this. Okay, so there is no something, we are updating our tail to head. That's why it's originating that problem. So if I remove this, so let's just do it. Set next node address to this dot head. So now this is okay, I think. Now our partial update should work. If I make a make, and it should print out like this. So see what's happening. So 66, 5, 77, 78, 88, 99. So 99 is removed. Okay, now our delete is working from the last position. Done. Deleting from the first index, 66 is gone. It's also working. And it was like deleting from the second index, right? Deleting on the second index. So which is our second index from India? 0, 1, 2. So the 78. So 78 is gone. So yeah, it's working actually. So it is actually working. So let's just make a clear out of it. Okay, so it's working the clear. So let's just go in here, and if I go to the main.cpp, and let's just for now let's just remove all this thing. Okay, so I'm going to remove all this. So I'm also going to remove all this. So this is this, so this is actually everything from so this is actually everything from this part. So this is implementing adding functionality, deleting functionality, and also traversing functionality to the circular linked list. I hope you learned something new from this, and you know how to find what are you doing when you are making a mistake, because I made mistakes and it's not deliberate. I made mistakes by myself. It was not deliberate. So I was doing everything in the real time, so you can see. So you can update all things like this. Don't forget to check out my link tree, and also if you like the video, please like and subscribe. And in the next data structure, what we are going to do is we are going to implement stack, which may take me 1 week for now because I will be busy in the next week. So yeah, thank you for watching. See you in the next video.